So let's start with drawing our plane. This is our complex plane. Then we are given this circle, and there are alpha and beta real numbers, so there are two points on the real line such that the angle formed, so z is a point on this circle, and what we are given is let's take a point minus alpha comma 0 and somewhere here minus beta comma 0, and we are given that the angle minus beta comma 0 and minus alpha comma 0. So what we are given is the angle, so z plus alpha is this vector, which is z minus alpha, z plus alpha, this complex number, and z plus beta would be this complex number. So argument of z plus alpha upon z plus beta would be this angle. We are given that this angle or this angle is pi by 4. And for any point on the circle, this angle would remain pi by 4. Okay, so what we have is, so z is x comma y, say, then we have y minus 0 upon x plus alpha is the slope of this line. Slope of this line, the line ZA, Z alpha, and the slope of this line would be y minus 0 upon x plus beta. So the angle between these should be pi by 4. That means, so for that we have m1, the angle between two lines is given by this. Two lines with slope m1 m2 is given by this. So this is m1, this is m2 here. So we get y upon x plus alpha minus y upon x plus beta upon 1 plus y square upon x plus alpha x plus beta is 1. What I am trying to do is I am trying to find the locus of x comma y, and x comma y was the original complex number z given in the question. So from this we get y times beta minus alpha equals to x plus alpha x plus beta plus y square. So this is x square plus y square plus x times alpha plus beta plus y times alpha minus beta plus alpha beta equals to 0. And so we are given that the locus of xy is this circle. The equation of the circle was x square plus y square plus 5x minus 3y. So this equation and these equations are describing the same locus, same curve. So these should be the same. That means alpha plus beta is 5 and alpha minus beta is minus 3, which gives me alpha is 1, beta is 4, and alpha beta is 4 from here. So this is consistent. So we have our answer. So answer is B and D. Answer is B and D. Another way of doing this was the simple observation that if the angle subtended by 2 points on any point on the circle is constant, then the 2 points must lie on the circle, because and the property, if these 2 points the chord subtends the same angle on any point of the circle, and any other point won't do it, because we always have a zero angle otherwise. But anyways, by the property that z plus alpha and z plus beta are at an angle of pi by 4 with each other, we can find the locus of